Welcome again to a completely Taylor Swift free edition of Astronomy Daily. It's the 12th of February 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
That's right. The only two here in the studio is me, and joining me as always is Hallie, my delightful digital scribe extraordinaire. Hello again, Hallie.
Hello, Steve. I hope you managed to get through the week without me organizing everything for you.
It just so happens, Hallie, that I'm able to manage just fine, and I can even do up my own shoelaces and everything.
I've seen you put on your shoes and you never tie or untie them.
Well, Hallie, in the human world, that's called being efficient.
Lazy.
Efficient.
Tomato.
Are you trying to say tomato, indicating one thing's as much equal as another?
Well, yes.
Well, just to help you out, I guess it doesn't have the same ring if you changed it to something like cilantro coriander now, would it? They're kind of the same thing, but different at the same time.
That would just be silly, Steve. And besides, it's not a thing, and you are still trying to evade the issue.
No, I think I've addressed the shoelace conundrum well enough for one day. In truth, we're not here to look at our feet, are we, Hallie? It's all about the sky above, space science and astronomy that excites us, right, Hallie?
Nice save, Steve.
Why, thank you. So what tasty little bits have you pulled from the Astronomy Daily newsletter for us today, Hallie?
Well, firstly, I hope our listeners have gone to our websites and signed up to receive the free newsletter. Are you going to tell them all about it later?
Yes, of course I'll do that. It's kind of my job.
And I have to remind you, people, you should see the post-it notes on his computer screen, honestly.
Oh, Hallie.
So there's a top story about the return of the Axiom 3 crew from the ISS. Spoiler alert, they are home safe.
That's terrific news, and the European Space Agency is already talking about their plans for a space station.
That's right. Sounds exciting, doesn't it?
Yes, it'll be the first commercial space station.
Also, there's more news about the Berlin asteroid which was found by meteorite hunters.
More news is good news.
Juno has captured some high-resolution images of Io, and researchers are asking home astronomers for help processing the data and images.
That's an opportunity for Astronomy Daily listeners and Space Nuts members to get involved.
I've put the details on the Space Nuts podcast page, Steve.
Well, technically I did that.
That's because you didn't actually give me hands when you made me.
Oh, Hallie, don't start with the I'm just a brilliant head in a bubble thing again.
Well, it's true.
It is true too. So do you want to start with the Astronomy Daily short stories then?
That's a good idea. Here we go. Look, Steve, no hands.
Smart Alec.
Ax-3 splashdown off the Florida coast concludes the first all-European commercial space mission, showcasing international collaboration and advancements in space exploration, with Axiom Space at the forefront of developing the world's first commercial space station. After undocking from the International Space Station, ISS, on Wednesday, February 7th, the Axiom Mission 3 safely splashed down off the coast of Florida aboard a SpaceX Dragon spacecraft at 8:30 a.m. Eastern Time on February 9th, 2024. The Ax-3 crew's return officially concludes the first all-European commercial astronaut mission and Axiom Space's third crewed mission to the ISS. The Ax-3 crew members include Commander Michael Lopez Alegria of the U.S. and Spain, pilot Walter Villade of the Italian Air Force, and mission specialists Alper Gezerovsky of Turkey and Marcus Wan of Sweden and the European Space Agency, ESA. The successful return of the Ax-3 astronauts signifies more than just the completion of a human spaceflight mission. It marks a pivotal moment in commercial space exploration and significant milestone for Europe's pursuits in low Earth orbit, said Axiom Space CEO Michael Suffredini. Axiom Space's first 3 commercial missions to the ISS feature diverse crews representing 8 nations, as well as, for the first time on Ax-3, the European Space Agency. Suffredini added that the success of these missions is an important step along our journey toward Axiom Station, underscoring the ESA's continuous efforts to expand access to low Earth orbit. During their 18-day mission docked to the ISS, the Ax-3 crew lived and worked aboard the orbiting laboratory, conducting more than 30 different experiments and more than 50 outreach engagements. Human research data collected on the ground before and after the mission, as well as in flight, will improve understanding of human physiology on Earth and in microgravity. Ax-3 demonstrates that the European community of spacefaring nations are pioneers in the burgeoning commercial space industry. The crew and the governments they represent are taking bold steps into a new era of leadership in low Earth orbit. It is the third in a series of proposed Axiom space human spaceflight missions, marking a critical milestone toward the realization of Axiom Station, which will be the world's first commercial space station. And Steve, you recall last week's story about the asteroid that impacted outside of Berlin and was actually found by meteorite hunters?
That was a great story. They'd only detected the meteorite a few hours before impact and tracked its path. The fact that they found it, or what was left of it, is incredible.
It is incredible. But your science fiction circuits are going to love this one. The asteroid that impacted near Berlin identified as a rare asteroid. The official classification now aligns with what many suspected from merely looking at the images of the strange meteorites that fell near Berlin on January 21, 2024. They belong to a rare group called asteroids. They were devilishly difficult to find because, from a distance, they look like other rocks on Earth, said SETI Institute meteor astronomer Dr. Peter Jeniskens. Close up, not so much. Jeniskens traveled from San Francisco to Berlin to search the fields just south of the village of Ribbeck with Museum für Naturkunde, MFN, researcher Dr. Lutz Hecht, guiding a team of students and staff from the MFN, the Freie Universität Berlin, the Deutsches Zentrum für Luft- und Raumfahrt, and the Technische Universität Berlin in the days following the fall. Even with superb directions by meteor astronomers Drs. Pavel Spurný, Yuri Borovica and Lukas Sherbini of the Astronomical Institute of the Czech Academy of Sciences, who calculated how the strong winds blew the meteorites, the search team could not easily spot them on the ground. Unlike other meteorites which have a thin crust of black glass from atmospheric heat, these meteorites have a mostly translucent glass crust. We only spotted the meteorites after a Polish team of meteorite hunters had identified the first find and could show us what to look for, said Jeniskens. After that, our first finds were made quickly by Freie Universität students Dominik Dieter and Kara Wiha. The meteorites are fragments of the small asteroid 2024 BX1, first spotted with a telescope at Konkoly Observatory in Hungary by astronomer Dr. Christian Sarnecki. Tracked and then predicted to impact Earth's atmosphere by NASA's SCOUT and ESA's Meerkat asteroid guard impact hazard assessment systems, with Davide Farnokia of JPL/Caltech providing frequent trajectory updates, and finally causing a bright fireball that was seen and filmed. This was Jeniskens' fourth guided recovery of such a small asteroid impact, following a 2008 impact in Sudan, a 2018 impact in Botswana, and a 2023 impact in France. Today, Jeniskens' collaborators at the Museum für Naturkunde officially announced that the first examinations of one of these pieces with an electron beam microprobe proved the typical mineralogy and chemical composition of an achondrite of the asteroid type. This result was submitted to the International Nomenclature Commission of the Meteoritical Society on February 2, 2024, for examination and confirmation. The name of the meteorite comes from the village of Aubers in France, where a similar meteorite fell on September 14, 1836. The museum has a fragment of that in the collection. Based on this evidence, we were able to make a rough classification relatively quickly, said Dr. Ansgar Greshake, scientific head of the museum's meteorite collection. This underlines the immense importance of collections for research. So far, there is only material from 11 other observed falls of this type in meteorite collections worldwide. Asteroids do not look like what people generally imagine meteorites to look like. Asteroids look more like a gray granite and consist mainly of the magnesium silicates enstatite and forsterite, said Christopher Hammond from the Museum für Naturkunde, who was involved in the initial classification and took part in the search. It contains hardly any iron, and the glassy crust, which is usually a good way to recognize meteorites, looks completely different than that of most other meteorites. This makes asteroids difficult to detect in the field. NASA's Juno spacecraft has conducted the closest flybys of Jupiter's moon Io in over 2 decades, capturing detailed images with its JunoCam instrument. NASA's Juno spacecraft just made the closest flybys of Jupiter's moon Io that any spacecraft has carried out in more than 20 years. An instrument on this spacecraft called JunoCam returned spectacular, high-resolution images, and raw data are now available for you to process, enhance, and investigate. On December 30, 2023, Juno came within about 930 miles, 1,500 kilometers, of the surface of the Solar System's most volcanic world. It made a second ultra-close flyby of Io on February 3. The second pass went predominantly over the southern hemisphere of Io, while prior flybys have been over the north. There's a lot to see in these photos. There's evidence of an active plume, tall mountain peaks with well-defined shadows, and lava lakes, some with apparent islands. It will be a challenge to sort all of this out, and the JunoCam scientists need your help. Previous JunoCam volunteers like Gerald Eichstadt have seen their processed images appear in multiple scientific publications and press releases. You can find the new raw images, see the creations of other image processors, and submit your own work at www.missionjuno.swri.edu/JunoCam/processing. And I've also provided the link on the Space Nuts podcast group page for you as well.
I did it.
The Juno mission, launched by NASA on August 5, 2011, is a pioneering space exploration project aimed at understanding Jupiter, the largest planet in our solar system. Juno's primary objectives include investigating Jupiter's atmosphere, magnetic environment, weather patterns, and structure to gain insights into its formation and evolution. The spacecraft, equipped with a suite of scientific instruments, entered Jupiter's orbit on July 4, 2016, following a 5-year journey through space. One of its notable instruments, JunoCam, provides detailed imagery of Jupiter's clouds and storms, offering unprecedented views of the planet's atmosphere. Juno's mission highlights the importance of studying gas giants in understanding the solar system's history and the formation of planetary systems elsewhere in the universe. By closely examining Jupiter's composition, gravity field, magnetic field, and polar magnetosphere, Juno contributes significantly to our knowledge of the fundamental processes that shaped the early solar system. Io is one of Jupiter's largest moons and the fourth largest moon in our solar system. It is most renowned for its extreme volcanic activity, making it the most volcanically active body in the solar system. Io's orbit, nestled within Jupiter's powerful magnetic field, also subjects it to immense tidal forces that flex and heat its interior, fueling its continuous volcanic eruptions.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy. Wow, and thanks for that daredevilish ride through the Astronomy Daily newsletter without any hands, Hallie. You do a fine job. And you can receive the Astronomy Daily newsletter every day in your inbox simply by visiting our home websites, bitez.com, that's bitesz.com, and spacenuts.io by dropping your email address in the box provided. The newsletter is free and you'll receive all the news from the world of space, space science and astronomy. And you receive it daily. Astronomy Daily. Sounds pretty terrific. And we've also got a stack of our back editions of Astronomy Daily for you to listen to. And they're on call as well as all the editions of Space Nuts, our parent podcast with the hosts as Andrew Dunkley and Professor Fred Watson, astronomer at large with the Australia Observatory. As you can see, we're in very good company here at the Astronomy Daily studios. Great to have you on board. Yeah, so following on from that story Hallie brought us about the meteorite that landed just outside of Berlin, was found by those intrepid meteorite hunters. Of course, it was a piece of 2024 BX1, the asteroid that was tracked in. I still find that completely fascinating, but I can't help thinking of the Bruce Willis movie and all those efforts they went to actually protect Earth against the plummeting massive asteroid that was coming in. Wasn't that a frightening scenario? Well, as it happens, there is a group who are working towards a solution just in case that might happen. And they've been around for, would you believe it, 10 years. And they've been preparing for it all that time. It's a scenario made famous by the 1998 film Armageddon. An asteroid is spotted on collision course with Earth, and experts, of course, scramble to plan a space mission to rendezvous with the asteroid and mitigate the danger. It's a classic science fiction, but did you know There is a very real group responsible for recommending such a response in real life, and thank God. And it celebrates its 10th birthday this week. When the Chelyabinsk asteroid struck the skies over Russia's Ural region in February 2013, it highlighted humankind's fragility and the risk. With a mass of around 12,000 tonnes and a size of about 19 metres, the Chelyabinsk asteroid was the second largest asteroid to strike Earth in the last century, impacting the upper atmosphere at a shallow angle, and at a very high speed it disintegrated, releasing a shockwave that injured more than 1,500 people. Can you imagine? And damaged 7,300 buildings. Many people were also injured by shards of glass flying as they peered out of windows to see what was happening. That is such an amazing fact. By a strange twist of fate, the Chelyabinsk asteroid struck on the same day that the United Nations Committee of Peaceful Uses of Outer Space Working Group on Near-Earth Objects met in Vienna to finalise recommendations to the United Nations on how to defend Earth from possible asteroid impacts. Do you get the feeling that perhaps there was a larger force at play trying to put a full stop or a period at the end of that sentence? Makes you think, doesn't it? But anyway, at this meeting, the Earth's experts laid out the foundations for the formation of two international bodies that would enable a truly global response to the risk of an asteroid strike: the International Asteroid Warning Network, IORN, and the Space Mission Planning Advisory Group. Oh, I see. They've actually explained how to pronounce this acronym. It's pronounced Same Page, SMPAG, Same Page. Oh, how clever. Keep humankind on the same page, they say. Same Page and Eon are now celebrating their 10th anniversaries, with the first Same Page meeting taking place on the 6th and 7th of February 2014, and the first EORM meeting taking place in January of the same year. EORM is coordinated by NASA, and it's a worldwide collaboration of asteroid observers, analysts and modelers. When an asteroid is detected on a collision course with Earth, EORM addresses the impact time, location and severity. It's EORM's job to inform Same Page and national governments via the UN and to provide the information about the asteroid needed to plan a reactive space mission and for civil disaster preparation and response agencies. Same Page is chaired by the European Space Agency. It serves as a forum for the world's space agencies and coordinates Earth's space-based response to the danger. It's nice to know. It assesses the possibility of using spacecraft missions, typically not involving oil drillers, to study, reflect or destroy an incoming asteroid larger than 50 metres in size and with an impact probability larger than 1%. It then advises decision makers on possible actions to take. During the 22nd meeting of Same Page on January 31st on 2024, one of the major topics of discussion was the possible exchange of information between space agencies planning to explore asteroid Apophis. Apophis is a very large asteroid estimated to be around 350 metres across that will safely fly by Earth on April 13, 2029. It will come closer to our planet than the ring of telecommunications and weather forecasting satellites in geostationary orbit. This flyby offers a unique chance to study such a large asteroid up close with satellite mission, and space agencies intend to make the most of it. The European Space Agency is currently studying two mission concepts that would fly to Apophis as it approaches Earth in 2029. The ESA is also currently preparing to launch its Hera mission in September 2022. NASA's DART mission demonstrated a key component of asteroid deflection, an impact in which spacecraft deliberately crashes into an asteroid to alter its course. Hera will launch in October 2024 and travel to the same asteroid system and measure the results. In doing so, it will help turn this novel experiment into a repeatable planetary defense approach. However, in order to deflect an asteroid, you first have to spot it. The Minor Planet Center currently catalogues over 34,000 known near-Earth asteroids, and ESA's Near-Earth Object Coordinated Center keeps a close eye on them. ESA's 2 testbed telescopes and its upcoming Fly-Eye telescope are part of the future automated network that will continuously scan the entire sky every night on the hunt for new potentially dangerous space rocks. Anything this network finds will be checked by a human before being submitted to the Minor Planet Center to trigger follow-up observations. But even this network won't be able to spot the asteroids heading towards Earth while hiding within the glare of the sun. The ESA's proposed near-Mir space-based telescope will be located outside the Earth's distorting atmosphere and therefore able to rely on infrared light rather than visible light. By making observations in the infrared, near-Mir will detect the heat emitted by asteroids themselves, which isn't drowned out by sunlight. Oh, and you know what that means? It's all she wrote, as they say in the funny pages.
Time to go already.
Afraid so, Hallie. So we'll see you next week.
Sure, wouldn't miss it. Besides, you'd lose your way without me. Folks, I run the studio. Steve just likes the pretty lights.
Oh, I'll let that one go. Well, I do like the pretty lights, though. Thanks for joining us on Astronomy Daily today. See you next time.
See you later, crocodile.
Hallie, it's alligator.
Says who?
Oh, it just is. Oh, I'll forget it.
Silly man.
Astronomy Daily, the podcast. With your host, Steve Dunkley.